All right, hello everyone, and welcome to this discussion session on industrial software development practices. Do they work in academia? Should RSEs learn and use them? My name is Jeff Carver. I'm a professor of computer science at the University of Alabama, and I'm going to give you a brief introduction here, and then we'll introduce the rest of the panelists. So the focus of this discussion session is to try to understand whether industrial software development practices, which we'll develop that concept here as we go, whether those work in the development of academic software. So in this case, for this discussion, we mean a whole lot more than simply writing code. We're also interested in talking about all the practices that go around writing code, including things like requirements, design, testing, code review, maintenance, version control, and lots of other things as well. So depending upon how we answer the question of whether these practices are relevant, then we'll explore a little bit more about whether RSEs should learn them and use them, and if so, which ones should they use. So we're looking forward to an interesting discussion. So as I said, my name is Jeff Carver. I'm a professor of computer science at the University of Alabama. My background is in software engineering, but I've been working with and studying research software and academic software for a long time and looking at this crossover between industry and research. And so this will be an interesting discussion for me. So we'll just take a couple of minutes and let each one of the panelists introduce themselves, and then we'll jump into the discussion. So Ian Cotton, why don't you go first?
Thanks, Jeff. So my name is Ian Cotton. I retired last year, just over 12 months ago, after about 48 years working as a software engineer, both in academia, mainly with the University of Manchester, but also in industry. I've worked with spin-out startups, small consultancies, up to very large enterprises. So I've seen a bit of everything in the world, I think. So my last job before I retired was head of the research software engineering group at Manchester. And after retiring, I became a trustee of the society in order to try and give something back and contribute to sessions like this one. Thanks.
Great, thank you. Colin, how about you? You're muted, Colin.
Always the way. Good afternoon, everybody. My name's Colin Venters. I'm a reader in software engineering at the University of Huddersfield. My principal research area is in architectural level reasoning for sustainable systems. I currently lead the software engineering provision in terms of courses at Huddersfield in software engineering, and I currently head up the newly established Centre for Sustainable Software Engineering. I've got about 20 years experience of working in both industry and academia across a range of different domains, and principally focus on scientific software development at the moment.
All right, thank you. Ryan.
Hi there, everyone. I'm Ryan Pepper. I'm currently a senior RSE at the University of Birmingham. Prior to that, I worked for Siemens as a software engineer working on CFD software, where I was mostly a C++ developer and worked on solver components and the scientific side of it. Prior to that, I was doing my PhD at the University of Southampton, where I worked on magnetic simulations for nanomaterials. Thank you.
Last is Mark.
Thanks. Yeah, so I'm also a career software developer, about 3/4 of that time in academia, and a quarter in industry, from big enterprises to startups. I currently work in the Department of Epidemiology at Imperial College. Prior to that, I led the college's RSE team.
All right, great, thank you. So we have lots of good experience to share here during this discussion. So let me start off with trying to clarify some of the terms that we used in the discussion title. So the first question I want to toss out to the group and get us to talk about, what are the similarities and differences between academic software and industrial software? So, are there common challenges faced in academic projects for which industrial projects might help, and how are those two related to each other? So what are your thoughts on the similarities and differences between academic software and industrial software?
Who wants to go first, guys? I could kick us off in like the talk this morning from Graham Lee of Oxford. There are probably more similarities than differences, so I think that's an important point to start with. Of course, in the commercial world, everything's driven by profit and cost-benefit analysis, so that steers things in certain directions. Where researchers producing software might try and do the best they can to produce very high quality software. In industry, it might be just good enough to make a profit, that kind of thing. If there is one major difference, of course there are differences, lots of differences, but one major one is the very rapid change of requirements that research projects go through. Obviously some industrial techniques like the what you might term the old-fashioned waterfall approach aren't applicable. You just have to be much more agile in the academic scene. I'll stop there and let somebody else pitch in.
Oh, I'd agree with that. I'd say that actually it's slightly easier to identify differences than similarities. I mean, it's impossible to generalize in some respects, but like a small startup is principally focused on building a great product and satisfying its customers. And as companies grow, evolve and mature, then they tend to end up, looking more at the bottom line, I guess. But I think the important thing for me is that awareness of having a different set of customers. And in research, that might be a senior academic, it might be other developers of research software, or it could be end users. Much of the software we develop is actually intended for decision makers who have some domain knowledge but aren't technical. They may be trying to interpret data that we're helping to publish, and they need a user-friendly way of accessing that. And in that respect, outputs can vary a lot as well. But I think rather than developing a product, much of the time you are developing in academia some kind of tool, or it could be in support of research itself. It could be a paper or publication, which is obviously an entity in its own right, with a different type of consumer who's interested in that. And I totally agree with Ian there. There's uncertainty kind of at both ends. There's that question of the requirements for the end user, but it's also based on shifting sands of research. So there's a lot of exploratory work, and sometimes you might be embarking on a project where you don't know if something is possible. Whereas if you're building a product in industry, you could be very familiar with the technology and you can build that as a solid foundation. And then you're working more on what does the product look like and what are we trying to achieve for our users. So that's how I would summarize it.
I think I agree with most of that. I think one big difference I would say is that the existence of competitors in industry. There's always somebody who's got a similar sort of product out there. If they add a feature, you may have to add that feature to satisfy your existing customers, or you might lose them. And so that can put pressure on you to meet certain requirements that in academia similar sorts of things happen, but I would say that a lot of academics who write their own software and RSEs who work on those sort of things, they're interested in answering specific research questions, and the software can sometimes just be an output, as a side output of that. It's not always the primary focus, and that can be quite different in one sense, I'd say.
So to add to that, I agree with all the comments so far. I would say there are probably more similarities than there are differences, and I think, and I should preface many of my sort of responses by saying context is everything. It's very difficult to generalize given the types of software that's developed in industry, whether it's at SME level or whether it's at the enterprise level, and also within academia itself. But I think similarities, I think, also are around complexity and degrees of complexity in systems that we design, and also to do with things like technical debt and code smells. And that's also where you might find some of the differences. And I think you'll probably find more accidental complexity in scientific software in theory than you would find in industrial software. And also, perhaps around the environment itself in which the software is developed, which others have alluded to. I think there's different pressures. that drive things. But definitely, context is a big influence on some of the practices that are adopted.
Yeah, that sounds good. I mean, it sounds like also maybe some of the incentives are a bit different in how people are rewarded and how things are valued. But I agree. I think a lot of the things you brought out are good comments. I guess one other part of that question before we move on is, do we? Some of you have said there's some similarities and there's also some differences across various kinds of projects. So are there any kind of common challenges that academic software projects face that maybe we could think about how industrial practices could help address some of those challenges? So do we see any kind of commonality across projects that we might be able to use as a starting point?
One thing I would add relates to the context thing that Colin mentioned, was that when I've been working as an RSE, I would differentiate two types of research projects. There's a type where the academics and the researchers specify the requirements, and then the software is built entirely by professional research software engineers. That's one context. And then there's another very common one where academics, postdocs, PhD students have developed and continue to develop a lot of the software, and they bring in research software engineers to do some extra work, and you're working together. It sounds a bit derogatory, but I'd almost call that the pro-am model of academic software development. And the two are quite different, really, as to what practices and so on you can introduce, I think. I suppose technically there's a third. There's the kind of lone hero academic researcher who just sits at his desk and produces loads of code, and it may be excellent, it might not, it varies tremendously. Let me pass that on to others to continue while I think about what more I can add.
Well, for me, one obvious commonality is, well, there's two in terms of objectives. I mean, lots of things can vary, like team size or complexity, or perhaps the intended durability of software. There is some disposability around a lot of research projects by design or otherwise, but everyone wants their code to be reliable. The other thing is, I think we often depend on very similar tooling, right? I mean, regardless of what we're building, if we happen to be writing Python code, then we're going to rely on having good tools, frameworks available to us that are somewhat independent of the kind of code that you're writing. So having investing and being aware of those tools is obviously a common interest between industrial and academic developers.
Any other thoughts on that one before we move on a little bit?
I think I agree. I mean, fundamentally, we're all using the same tools, same languages. Things sometimes vary in that. I mean, I would say there's more inertia to introducing new technologies, maybe in an industrial context, whether that be for cost reasons, for licensing reasons, that kind of thing. But yeah, much of the same things are the same in terms of the challenges. At the end of the day, you want to get a product that works and put it out there for people to use, and the motivation in that sense is very similar.
Let me just check a point with everybody. I've discovered and learnt that the one thing academic researchers and postdocs, etc., aren't very good at is version control. And so with lots of projects I've worked on, that's been one of the top priorities, to make sure some things like Git and GitHub are introduced, and in the pro-am model of software development, that they use properly, if you see what I mean, by a daily, almost continuous integration. So do people agree that getting that across first is the most important thing before you try and introduce anything else?
Yeah, I think that's important to have that. I mean, I will say that I don't believe that everywhere in our industry does that as well as maybe people in RSE community think they do. I think there's maybe a misconception All professional software engineers have got blazing CI setups and everything works really well. I don't think that's true necessarily. It would depend vastly on the team, the company, and in both of the places I work, there's good things and bad things about everything, just in the same as it is in academia. You meet some academics who are very well versed in this sort of thing and can set it all up themselves and are great at it, and other people who they're not professional software developers and have never been taught it, and that's why we have things like software carpentry to try and educate people on that. And so I think it's important to get those fundamentals in first, definitely.
Just to take that a step slightly higher up and sort of build on the point that Mark made about reliability, is I think the common challenge is how do we adopt the lightweight software engineering techniques and approaches to the development of research software. And I think that's perhaps the biggest challenge across the board that we all face. I'm pretty sure it was Carol Goebel that said we don't necessarily need to transpose software engineering education onto the RSE community, but we need to pick those things that are most useful. And I think it's a question of identifying those things that are useful that we can sort of generalize about.
Well, as Carol Goebel is my wife, I have to completely.
I know that.
But, I couldn't disagree with that.
But maybe we can bridge a little bit. We're already kind of talking about this, but the other part of the discussion title that maybe it would be helpful for us to define a little bit is, what do we mean when we say industrial software development practices? So you've already mentioned version control, Git, those kind of things. Maybe that falls into there, but there can be lots of other things. So when you hear the term industrial software development practices, or you think about that in this context, what do we mean by that? What are your thoughts on the different practices that could be relevant? We'll dig into specific ones that may be relevant later, but just in general, what are we talking about?
Yeah, if I could just say something on that, because this really gets to the crux of the issue, doesn't it? There's the question of what is best practice for software engineering versus what's industrial or academic. I think there are some things specific to industrial software engineering which aren't always a positive thing. So obviously, I think in industry, you'll focus more on processes that scale up, because often it's quite unusual to have a team of 50, 100, 1,000 developers working on a single project in academia, but not unheard of in industry. This is how you scale up in terms of the complexity and scale of the software product itself, or the code base, and the number of contributors, although obviously some open source projects do handle this. But some of it also comes down to metrics, right? That there's this obsession in industry sometimes with measuring things. And actually a lot of the processes adopted, like, we look at story points in terms of specifying or working out the current state of a project. Management love to better work out how many points we did in the last sprint or whatever. So there's a lot of tooling built around that. And that's one of the things that isn't lightweight and shouldn't necessarily be adopted without careful consideration. But also a lot of stuff in industry is based around churn in terms of software and the direction of a company, and in terms of developers. I don't know what the half-life is of a developer in a particular big tech company right now, but it's like a year or maybe 18 months maximum. So I know people leave in academia and are often on short-term contracts, but it's dealing with a slightly different problem. And I think in industry as well, people have clearly defined roles. You might have people who do front-end or back-end or even Scrum Masters or whatever, and we don't necessarily have that in academia. So the tooling, again, that we use has to be a little bit more versatile, and the processes have to be a bit more lightweight, I would say.
Totally agree. I think the team makeup's very different. It's not unheard of to have dedicated people working on testing, dedicated people working on, servers and DevOps type things. I will say, you obviously you might have 50 developers or 100 developers working on a project, but at the same time, they tend to be split up into smaller teams, which each will, work on a section or something like that. So you might have people who primarily work on the graphical user stuff, or people who work on, if it was a scientific project, the scientific parts, that kind of thing. And people jump in and out of those small sub teams all the time in industry. And I think that's more uncommon in academia in some ways. Like, yeah, obviously you have short-term contracts and things, but people might come develop a new part and then leave, and that person, depending on the project, they may not maintain that after that. It's not uncommon in academic projects for there to be, various bits that are sort of bolted on. I think that's quite common, and certainly if I look at the big software projects that I've used in an open source world, from scientific things, PETSI and Phoenix and stuff, you see that people have come in and written a part that's for their interests, and the maintenance stuff after that's not always considered so much. And so, in terms of like in industry, there's always got to be someone responsible for something if people are still using it in a way that maybe isn't the case in academic software development. So I think that's one thing that could maybe be a positive to bring in. But on the other hand, who funds that and who does the work is a big question that's always very difficult to answer.
One of the things that I think industry does a little bit better is documentation. And by documentation, I mean the upfront stuff. So requirement specifications and functional specifications. You say what you like about Microsoft and the Office products, but they've all got very, very detailed specifications. So that if, say, for example, there's the famous case of if you want to rebuild Excel according to the specs, you've got to reproduce some of the well-known bugs to make sure that you get the same results and so on. But I find it very hard to even get a requirements spec out of academics when I've been working with them. Sometimes they hide behind the rapid change and the agile method, so they say, well, we'll have Kanban boards and we all know what we're working on. So that's a kind of specification. But then one day you suddenly find what you've produced isn't what's really wanted at the moment. The sort of validation problem. But you were sent off down some technical routes. So I don't know what the answer to that is, but I raise it as an issue.
So
just to follow up on some of those, sorry, Jeff, just to follow up on some of those points, I think, industry has perhaps more clearly defined process with more clearly defined roles and more clearly defined outputs, where I think in academia, it can be one person that has to fulfill all those roles, but perhaps there's an overemphasis on coding rather than thinking about what the requirements are and some lightweight documentation around specifying those requirements. And perhaps there are some interesting stuff around testing, which also seems to be something that we miss a little bit in scientific software development. And perhaps, some of the practices that can be adopted are really around sort of rapid prototype development as a way of exploring the uncertainty that sort of exists within the field of science.
Yeah, I mean, we're already kind of talking about this, so I just want to see if there's any other thoughts on other, we've begun to talk about practices that happen in industry that don't happen in academia. Are there other practices that anybody thinks about that they see in industry that, again, something very heavyweight, very, very heavy process may not be relevant, but are there other practices that we are aware of that are more common in industry that might be relevant for academic software projects to consider adopting?
I think it's much more common in industry to have, a clearly defined release cycle. I would say most academics will do a few updates, think about it maybe, and then they'll go, oh, I'll release that. And then, releases can be intermittent after that. Even if someone's actively working on the project, if it's a Python project, for example, you might see things come up in PyPy in odd intervals, whereas in industry, if it's a web type thing, you're probably going to see updates fairly frequently. If it's like a big project, more traditional software development, you're probably going to see releases every 6 to 12 months. And I'm not sure whether there's really a a need for that in academia, but it's certainly a big difference because it sets your whole working year up, and the structure of your day-to-day work as well.
True. I think another area that's quite common in industry is code reviews. Where people review each other's code, not just against some coding standard, but looking for errors and that kind of thing. And it's reported. I'm not sure how strongly this is that such code reviews can discover a lot of bugs that would get through testing and so on. Now, whether I haven't seen that used much in the academic world, and it might be difficult in the kind of pro-am context I mentioned, where you've got some very experienced RSEs producing what's hopefully a very high quality code, and then some other slightly less high quality code being produced that to run a kind of mixed code review there might be quite difficult. But it's something to think about, even though I haven't got a perfect answer for that or anything.
I mean, to come back to my original sort of statement, the context is everything. What I've seen in industry is that there is much more design. It doesn't have to be heavyweight design, but it's a way of exploring and reasoning about the system that's going to be built. So there's much more of that approach to it, particularly from a software architecture level.
Mm-hmm.
Yeah, and it depends on the nature of the team. So I'm part of an embedded team now, and we simply agree a lot less upfront than we did as a central RSE team serving customers really within the university. So it's very different. On code review, we find that invaluable, and I think that is done more widely in industry, but mainly because the economies of scale that big software teams kind of offer, and I think it's great as a means of spotting bugs, but also skilling up more junior developers. And on those economies of scale, I think likewise, having people dedicated to developer experience or tooling or infrastructure, that can really accelerate, a team's ability to write code and to iterate and to move fast. And a lot of RSEs or people who are writing code as part of their research don't have that luxury. But there are small steps that you can take to make your life better, but no one's going to spend full time effort doing it for you.
What do people think about pair programming, which is often seen as part of an agile approach? I've seen it used in several industrial contexts, and personally I quite like pair programming, but haven't used it in the academic world. So again, experience and thoughts on that?
I also really like it. I think it's really useful. I think reasoning about things with other people, sometimes they just challenge you make assumptions that may not hold to be true, but either lack of experience or lack of knowledge about the domain might lead you to believe one thing when the opposite's true. In terms of that, using it, I've done it in both. Mostly, I'm in an RSE in a team which, like you said earlier, you're helping people in departments more like a client, I suppose. And so, often I find it easier, especially during the pandemic, to ring people up and say, well, show me your code, can we talk through it and that kind of thing. I find that really useful exercise. And, you get to see it as well. If you're trying to help somebody that's a bit more junior, then, you can see what level they're at really a lot more clearly than if you're just sending code backwards and forwards to each other. Like, I find it much more practical.
Yeah, I would support that. I think there's a lot of benefits to be derived from paid programming.
Yeah, one other thing I'll bring up, Colin, you mentioned design. I think something I always tell people is that they're doing design, whether they acknowledge it, whether they formally document. I mean, when you write software, you're doing design. You're designing, you're architecting the system. You may be doing it well, you may be not doing it well, you may be formally doing it or doing it ad hoc, but I think, that it happens. So I think the argument could be, can you make that a little bit more formal, or at least a little bit more conscious of the choices that are being made and the trade-offs which maybe that's something that's done a bit better in industry, that they're conscious of the design and conscious of some of those trade-offs that may or may not always happen in academic setting.
Yeah, I'd agree with that.
Yeah, I think one thing I would say is that awareness of design patterns in particular is much better in industry than it is in academia. You know, people know more about formal design patterns often because either they've been doing software engineering full time for longer, or because, you know, they're trained as computer scientists or things like that, where you might pick those skills up. Whereas, you know, most academics, even if they write a lot of software, tend to be in one domain, I would say. You know, they rarely step outside of that domain to write software. And so it's harder to pick those sort of patterns, you know, for solving known problems up, I would say.
Great.
So maybe we can flip this discussion to the other side for just a minute and think about, are there any potential drawbacks or negatives to trying to bring some more industrial software practices into the academic research software world? So we've been talking about some of the reasons we might want to bring some things in, but what are some of the barriers or the potential drawbacks that might happen in those cases?
The overhead is a big one. You know, the more processes you introduce, the more overhead there is, the less time you spend actually writing software, and the more time you spend thinking about writing software and talking about it. You know, I think that can be a significant time constraint. You know, if you're spending lots of time planning, for example, then, you know, but obviously there's a trade-off in all of that. You know, sometimes planning is great, but also, you know, you might have 30 or 40 stakeholders in the business or something like that, and then, you know, it almost is a talking shop, isn't it? It can take a lot longer to get things done. Yeah, I don't know. I think the overhead in general is a big thing.
That's an interesting point that sort of Ryan's raised. If you've ever read The Mythical Man Month by Fred Brooks, he argues that, you know, only 1/6 of a project should be devoted to actually writing the code. The rest of the time should be spent looking at the requirements and testing that the system works, and sort of revisiting these things. So there are arguments about, well, if you really understand what you're supposed to be building, then it's easier to write the code. I do think that we tend to write code first, and the software emerges from that. And I think that's a pathway to problems, I think.
For me, it's a matter of awareness, really. It's not about adopting these processes at all costs. It's particularly if you haven't spent time in a highly professional software development shop, or perhaps if you haven't studied computer science, that's a whole lot less relevant in my mind, then you don't know what you don't know. So you'll be writing code and you won't be aware of the tools or processes that can help you do it faster, more reliably, etc. So I think, as with everything, it's a matter of how you manage the overhead. You bring in things which improve your life, and do that judiciously, and keep an eye on the complexity and the time it's going to take new people to get on board and up to speed with those processes. But yeah, information is the valuable thing about what is possible. And I think people like Carpentry and the Turing Way are doing a great job of promoting best practice, but with a very kind of pragmatic bent.
We touched on it earlier, but I think one thing we don't want to bring in from industry is the idea of specialisms. You know, that you have somebody who's just does testing, or just does QA, or is a technical writer. You know, that's not going to work. You know, we've all got to be generalists in the research world, and I think that's working pretty well, really.
Yeah, I agree. I just don't think that we have enough people in academia usually on a project to do those defined roles.
I'd also say that tooling, having good tools, can be problematic. You know, particularly if you're dealing with legacy software. You know, how do you, in the absence of good documentation, how do you understand the software that you have? And I think there's a lack of good tools that help, don't allow us to understand the software that we have in front of us, as well as perhaps, things like architectural recovery. I've had a couple of students look at, the quality of some scientific software And even sort of static analysis tools were quite problematic, for them to even install and then use. So there's quite a high learning curve, and perhaps, you know, the academic community are not quite ready for those. But perhaps there are elements of that that would be useful for them to understand and apply.
I think that's interesting, because in my last job, I definitely saw that, you know, those tools set up. Also, security audit type things tend to be much more common in industry, I think. You know, I doubt very many people in academic software have run security audits against their software. And maybe there's a place for that at some point, but it's very difficult to see how you'd integrate those things. Often you know, it's either audited by a third-party company, or, you know, you have some automatic software that's commercial to try and pick up those bugs as well. So it's probably be quite difficult to adopt that.
Are there other barriers that you can think of that might, even if a particular practice might be useful in the academic software world, are there other barriers? I mean, we've mentioned tooling, we've mentioned maybe even a lack of knowledge. Are there other things that could prevent the adoption of some practices that might be useful?
I think funding's a big one. I mean, just as an example, you know, I know that in my old thing, we still supported versions going back a long time, because people paid maintenance contracts to maintain those versions. So, you know, I think if someone came to an academic software project that was open source and said, you know, there's a problem with this version, you might get an answer of, well, upgrade, or, well, make a pull request. And so I think that's good in a lot of ways. You know, you need people to help out if you want to keep these projects to be maintainable going forwards. But at the same time, you know, it can be very difficult. I know I've been on the receiving end for some biting open source comments, like, why isn't this working, that kind of thing. And you know, if you just don't have the time to do it because, you know, you're not funded to do it, then that's very difficult in academia, even though, you know, maintenance would be beneficial to people using the software.
I'd agree. Related to that is payback time, right? Some infrastructure takes a while to set up, and it might not pay itself back overnight. So there's a question there about how you demonstrate the value of some of these approaches. I think awareness is the biggest issue. There is also a bit of a case of exceptionalism within academia. People saying simply because this is in industry, we shouldn't need to adopt it, or there's something about our projects. We need to be so agile that this stuff actually slows us down. But in reality, I mean, I've never seen a project in academia that's been over-specified, or the requirements have been gathered too carefully. So I think there's a lot to learn. I think you have to take some of it on trust. Like, I think sometimes the people I've worked for or with have felt like we're moving slowly, especially at the start of a project, and they could have knocked something together, you know, a lot quicker. But as I say, I think if you want a solid foundation, sometimes that takes a while to set up, and that does involve investing in researching and as well as installing, configuring the right kind of tools and processes.
I think there's a tendency in the academic world as well to use one's favorite programming language, you know, irrespective of the type of project and the type of problem that's trying to be solved. So, for example, you might be working in some almost safety related area, but your favorite language is C or Fortran or something, you know, so that's what it ends up being written in, rather than perhaps, you know, a Prolog, a Lisp, or a MATLAB, one of the more higher level languages that are more suited to correctness arguments. Just an observation.
No, that also applies to something I think Ryan said about, you know, there is a lot of freedom to experiment with not a lot of oversight sometimes. So that involves people picking up new stuff and trying to apply it to totally inappropriate areas or domains. The classic one is people coming to us and say, we want to use a technology like Kubernetes, or we want to use an approach like AI, and applying it to totally, you know, irrelevant cases. And that's when you have to be pretty strong, but also have a justification that, you know, you invest and trust in our knowledge because we have some relevant experience, and it might not include all the buzzwords, but c'est la vie.
So as we're getting close to the end time here, maybe one more question. See if everybody has a thought on this. If you could advocate for a RSE to learn one or two specific industrial practices that kind of fit all of the context that we've been talking about, what would your suggestion be? What would be your top one or two practices that an RSE should know from industry?
I'm going to suggest something around software architecture since it's my field. And I think there's some very useful lightweight approaches that come out of that. The first one is the 4+1 model by Philippe Cruikshank, which gives us different views of the architecture. I mean, I often think that people get confused about what software architecture means. There's no such thing as one overarching view of the system. There are many views of the system. And I think Cruikshank's model gives us enough insight into how that system is related to the different aspects that go into its build. And related to that sort of overall design is something known as architectural tactics, which is one step down from design patterns. And there's a whole catalogue of tactics that help us solve fairly well-known problems to do with things like maintainability, to do with performance, to do with reliability, etc. And so that's the thing I would suggest.
Great. I think I go for writing and maintaining better documentation right from the very beginning of requirements documents through to maintenance manuals. Really, all the stuff that most software engineers absolutely hate to do, but perhaps with practice you can learn to love it. Over to you.
I think I advocate for some sort of planning type skills. Being able to conceptualize the project, break it down into smaller pieces that are sort of achievable to work on. I know that's very agile, but I quite like that way of working. And I think there's a lot to be said for it, to be honest. I think often in academia there's sort of like a big end goal in sight, but people just slog away at it for a long period of time without really trying to break it down into more achievable chunks. And I think it's a really useful skill to have in software development.
Yeah, and I agree with all of that in terms of process, but from a practical perspective, for me, it's simply version control. I don't think we should lose sight of the fact that
Yes.
we haven't even won that battle yet. And I think it's so foundational because once you've done that, you can move on to automated testing, the sort of the QA, then the CI and the CD. It's a litmus test for me when I come to audit a new project. It's very rare to find a well-engineered project that doesn't effectively use version control, and likewise a PI, a research group that completely disregards it. That it's an early warning sign that the code is going to be somewhat inaccessible, literally and metaphorically. Yeah.
Agreed.
Well, good. Well, maybe just with the last few minutes we have, maybe we go around one more time and see if everybody has any just kind of short closing remarks, any overall thoughts from the discussion. I can just kind of call on you one at a time and maybe a minute or two for each, and then that should take us to our end time. So Ian, do you want to have any closing thoughts?
Yeah, we mentioned earlier, I think, how RSEs learn some of these things. Well, in most environments I've worked in with RSEs, there's a sort of continuum of experience, really, from new graduates starting as RSEs right up to people with decades of experience. So I think the thing to do is, once you've established what these tools and techniques are, to have internal training programs to bring all the RSE team up to speed, and not just assume, that people will sort of pick them up on the job, which I know I've been guilty of in the past as well. But that's one of my last remarks, given the time.
Let's see, Ryan, how about you?
I think one of the nice things from this is, I think there's broad agreement among most RSEs and people in the RSE community of, the fundamental stuff. Like, I know Mark just said version control is fundamental. I know you said you've not won that battle, but I think among RSE types, we definitely have won the battle. It's, I Git version control, testing, continuous integration. I would say those things are almost assumed now for most RSE projects, or well, there's some involvement anyway. And while yes, I agree, there's a lot of work to be done in bringing that out to academics. You know, I think I would say that's a broad stroke thing from industry that we've definitely adopted and are spreading anyway.
Mark?
Yeah, I mean, three really quick points. Just come back to that thing that there's not industrial academic. There is best practice, and you just have to apply it appropriately. I think the best way to learn this as a software engineer rather than academic, it is spending time in different environments on different products with different teams. So that may be spending time in industry. So that's never time wasted. It might be contributing to large open source projects. I mean, I've been doing this for a long time, but recently submitted a patch to Pandas, only a documentation patch, but their QA process was completely unknown to me, unfamiliar to me, and quite remarkable. So just doing that, you can learn something. And we shouldn't forget that there are differences. I mean, a lot of industrial processes don't relate often to HPC or to domain-specific languages, perhaps like Fortran. So in some cases, we do need to invent our own solutions, but it's quite rare. I think the wheel has often been invented elsewhere. It's just a matter of doing a bit of research.
And Colin?
I think one of the things we need to think about is how we sort of really raise the awareness of good practice in an academic environment, and those, what are those lightweight software engineering methods, approaches, techniques that are applicable. I mean, one of the great things about the field of software engineering, there's many ways of achieving the same thing, but that also creates a bit of a headache. And I think it was Ivor Jacobson at ICSE 18, he said that the software engineering community had been in a methods war for 40 years. But there's lots of good examples that can be applied that don't necessarily require a high learning curve, particularly around things like software architecture, design, and the application of things like patterns and tactics to solve problems. So I think it's how we sort of raise that awareness.
All right. Well, we are out of time. I want to thank all the panelists for the great discussion. There was a lot of thought-provoking comments here, and hopefully this discussion will continue on Slack and other places. So once again, thanks for attending, and that will end this discussion.
Thank you.
Thanks, everybody.